Hello there and welcome back to the channel. Today we're going to be talking about this, and this is my original custom-made DJI battery charger for the Inspire series. Now I originally built this about 4 years ago for my Inspire 1 and then converted it to my Inspire 2, and in this video we're going to actually do a repair on it because one of the onboard power supplies is blown up, and this isn't the first time that this has actually happened, but it has happened to me again this weekend. So in this video we're going to take a look at this charger again, give you guys another overview of it, actually take a look at the power supply, what's actually gone wrong, we're going to repair it and get it back up and running. Now if you haven't seen this, I did a number of videos on the build log of this in the past, and if you're interested in them, please do check them out. I'll also put a link to them in the description of this video as well, but I will give you guys another overview of this one at the same time because it's one of my earliest projects, and actually it's probably been one of my best ones. Anyway, let's get on with it. I'm going to give you a quick overview of what it actually does first, and then let's take a look inside at what actually has gone wrong. Okay, so just to give you guys some background, this is a custom 4 battery charger originally for the Inspire 1 but converted to the Inspire 2 TB50 series. It will charge up to 4 TB50s individually, and it will charge them to either fully charged position or to storage charge when you drop the switch down. And the way it works is it has an Arduino on board which is programmed to read the voltage of each battery. It displays that on the onboard display, but it also then controls the charge voltage as well to allow you to set it to about 3.85 volt per cell. And as I said, this is a build I did about 4 years ago. It's got its normal mains input, it's also got a Crystal Sky battery charger for the Syndent, it's got a USB port, and there is a button here which I was going to do for something else, but that one didn't actually quite work out. Now when I built this originally, I used some standard 24 volt switch mode power supplies, and I actually built the whole thing myself. Now the battery holders were 3D printed, and I used actually the original Inspire 1 extension cables, and then when I converted it for the Inspire 2 I actually had to modify the remote to battery charging cable and fit these inside these custom printed holders. Now these never actually came out too well, but the fact that they've done the job means I've been able to continue to use them. Now I've removed all of the screws, and if I lift it up you will see the horrors that lie within. Let me just do that, and what I'll actually do is let's zoom us out and up a little bit just so you guys can actually see what is going on in here. Now as I said, I completely made this myself by hand. It was a one-off. I had plans to sort of tidy it up, but the reality was it just worked, so I never ended up doing it. Now just to give you guys an overview, you can see that you've got the wires off the TB50 battery connectors which come down into a relay board, and that simply controls what's turning on and off, and that then goes to a custom board with a small Arduino on board. And what that does is it reads the voltage from each of these positions, and then when I put it into the storage mode, it basically reads the voltage to a certain point and then cuts off the relay to stop charging the battery. There is a small buck converter on board for powering the onboard USB port for charging a tablet and things like that. And again, the board I used for making this was all custom, and I went over that in my video. It's got a voltage divider on board, it's got a small buck converter for powering the Arduino, it's got a regulator on board as well. And again, whilst it does look very, very messy, once I actually built it and got it working, I basically left it as that. Now, the main unit consisted of 4 switch mode power supplies. Now these were cheap ones I bought off Amazon or eBay, I think it was at the time, designed for 24 volt up to 6 amp output. Now as you can see, I've removed one of them because one of them has actually failed. I was using the charger the other day, I got a whiff of smoke, took a look across, and the voltage from one of the battery readouts was 0. Now this isn't the first time I've actually had this happen. It's the second time, and having a quick look at the power supply, it appears the same thing has happened again. So what we're going to do now is switch over to the power supply, take a look at what's actually gone wrong, and we're going to get it repaired, get it back in and test the charger to make sure it's all up and running. Now this is the power supply that I have already removed. As you can see, it's just one of the metal cage switch mode power supplies with your standard live, neutral, input and earth. You then got negative, positive and a little pot down here for adjusting the voltage output. Now the numbers on these is S150-24. It's rated at 6.5 amp, 24 volt DC. Now these will actually go up to about 27 volt in total, and that's why I chose these supplies to use. Now these were very, very cheap ones. I didn't spend a lot of money on these at all, and the reality is the fact that they've lasted as long as they have has been a bit of a bonus, because when I was building the charger I didn't know if it would actually work, so I didn't want to spend too much money on it. Now I could have actually ended up replacing all of the 4 switch modes with much better brand new ones. However, I've had one blow before and fixed it, and it looks like it's the same problem again, and it's a cheap fix. It's simply a capacitor that's let go on the switching circuit from the looks of it, because I can actually see it through the grill. So what we're going to do is take a look at that. Now it's probably not easy for you to see there, but if I zoom the camera in, actually let me bring it up much closer to the lens and focus. If you look, you can start to see that capacitor on the side there. It's hard to see it, but you can see a bit of a split going on right there on that capacitor. So what we'll do is we'll get the casing off and have a proper closer look at it. Okay, so I have removed the case, and as you can see, it is very clear something has gone wrong, and that is this capacitor right here. Now what's actually happened is it's blown out, and it's one of the film capacitors on the switching side of the PSU. And what happens is it makes quite a bit of a spinning smell, and when it shuts down it then stops the PSU outputting. Now it is a fairly straightforward component to change. It is simply a capacitor. I've bought a pack of them off the internet for I think about £2. It's actually labelled CL21 400 105J, so it's a 400 volt, and I think it's 1 UF is its total capacity. And reality is we simply need to just change that one over. Now it is a pretty traditional style switch mode power supply. I've had a quick look over it. Nothing else looks out of place. The 2 caps over here look good. There's nothing, no bulging on the tops or anything like that. I've had a look around the board as well. I'm not seeing any other issues with any of the other capacitors. Nothing on these other film ones either. Everything looks in order, and it simply looks to be just this one down here. So what we'll do now is get it out of the chassis, get the soldering iron fired up, and let's get him replaced. Now to be able to get it out of the chassis, I actually need to remove some clamps, because the heat sink for this is part of the frame. So a couple of the onboard transistors actually bolt to the outer shell. So to be able to get the board off, we actually have to remove them. And you've got like a link here and a link on the back as well. So the first thing we need to do is get them off. Now for this one over here, I can actually simply just rotate it up out of the way rather than completely remove it. I don't have to get him totally out. We've then also got a screw down here in the bottom corner as well. And what this should then do is, once removed, free it up. Now whenever you're touching a power supply, it's always worth being careful, because you have got these slightly larger capacitors on board. This has actually been off for a couple of days now, so it should be fully discharged. I took it off while I was waiting for the components to arrive that I needed. It's also worth noting that some of these transistors that are mounted to the chassis are isolated. Now this one here isn't. It simply just has a little bit of heatsink compound connecting to the chassis. However, this one on the back does have a thermal pad which gives it some isolation from the metal, because they are the style with the back end of them may be conductive. So you do need to be aware of that when replacing them. If there is any isolation pads in place, you do need to make sure that they go back. Now what I should be able to do is simply lift the board out, take it out of its aluminium chassis, and then that frees us up to be able to get to the components below. Now again, what we want to do is be replacing this capacitor here, which is just on these 2 legs over here. So what we need to do now is get the soldering station fired up. For this, I don't need to use the hot air gun. I can simply use the soldering iron itself. So I'm going to turn the hot air station off, get the iron itself warming, and we can simply use a standard soldering iron tip on this one to be able to get him replaced. Okay, so what we're going to do is we've got the soldering iron heating up nice and hot. I've actually got a very small nib on this one here. I mean, it'd probably be a bit smaller than I would like, but it will be fine. I've set it at, what have I set it at? 470 odd degrees, which will give us plenty of heat. So the first thing we're going to do is actually just put some more solder on the two pads. And what we're looking for is this one here and this one here, just because a lot of the time on these things they've used lead-free, which makes it slightly more difficult for removing the components. So the idea is just to put a bit in there. We're going to get a pair of pliers on him as I just get something to grab, as we're going to want to remove him. Not the easiest thing to do when I'm upside down, but there we go. I think we've got him off one side. Let's have a look. Yep. And actually it's the second pad back for the other one, which is this one here. Don't want to put too much on there. And again, we're just going to put the pliers on just so I can put a bit of a grip on him. Give him a bit of a tug. And there he goes. And that is him removed. Now, as you can see, it has quite spectacularly let go. Actually, let me just focus this for you so you can actually see it. Yeah, it has quite spectacularly let go, this has. So we're going to replace it. Now I've got some more. I've bought some. They're actually slightly larger than new ones, interestingly, but the rating is the same. So touch wood, we're going to get them in. So let's get that refocused. I think about there will do. We're going to flip him over, make sure there's no residue left on the board. There's a little bit where the where it actually let go. What we're going to do then is take a new one now, because this one is actually a tad bigger. We're going to actually have to do a little bit of a bend with the legs on this one. So what my plan to do is just to go in and in like that, and then we'll create a slight bend to allow it to go in, and it will sit a tad higher, but it certainly won't be anything to be concerned about, and it will allow me to actually get it in like that, and we'll actually end up in the other two holes rather than the ones, and I'll probably go that way around, which just gives a little bit more clearance when I'm comparing it. If I just pop them in place so you guys can see that a bit better. I've put a slight bend in them. Let's zoom in so you can see what I'm showing you. There we go, a second. There we are. Okay, so what I've done is put a slight bend in the legs to be able to get it to go in. So what we're going to do now is pop him in place, flip him over, and what I'll actually do is I'll cut the tags on this after it's fitted, because it will make life a little bit easier. So all I'm going to do at this point is warm up the solder point just to allow it to poke his way through, and because we are using the closer one this time, I'm just going to do it that way. And then what I'll actually do is snip off the wires afterwards rather than do it before, because that way it'll allow me to get the length right. And again, it's not the ideal way of doing it, but it's certainly not the wrong way of doing it either. Oh, cancel Siri, cancel.
There's nothing to cancel.
It's always slightly concerning when Siri gets involved when you're talking about electronics. It does make you wonder who else is actually listening. So, taking a just quick look at that, let's just have a look how he's in. Yep, I'm happy with how that looks. That all looks okay. So what we're going to do now is actually do it a lot tidier. So we're going to put plenty of solder on there, and then we'll actually snip it flat afterwards. take the solder off him. That's fine. Always the trick to make sure is actually you don't have too much solder on something like this. You don't want large bubbles of it. You just want the right amount. Perfect. Good. That'll do for this. So what we're going to do now is snip them down flat. So I'm just going to grab my snips. Make sure when you have snipped it, you take the bits of wire off. What I am going to do then is literally just touch them back up after I've snipped them ever so slightly. Just make sure they are nice. And overall, that is that one replaced. And as you can see, whilst it is slightly larger, it does fit in. There's no chance of shorting. There's no chance of it hitting the gaps. So we're all ready to put the power supply back together. Okay, now just as I mentioned at the start, something to be aware of before we put this back together is these transistors. This one here is not needing any isolation. However, these two here do have the isolation pad on, so you do need to be careful when you're putting it back in the metal chassis. Now, this one here did actually have some heatsink compound on. Now, what I'm going to do is just put a small squeeze of thermal compound on it, because it always helps with the heat transfer on these things. Now again, this one over here is a thermal pad. As you can see, we've taken him off, and there is some very light thermal compound on here, but what I am going to do is just put a touch more on, just to ensure that we do get plenty of thermal conductivity on these when I am putting him back. And again, it is just making sure that when you do it, you do have it in the right place and that there's no chance of it actually touching the metal chassis. So what we need to do now is get our metal chassis in place, take our PSU and then pop him back in, being careful to get it into the grooves in the chassis, because you want to make sure that your PSU is not touching the base of your chassis at all. It must always be touching on the existing built-in points. If you look down the back end, you can see that there's some little grooves in the aluminium cut out to allow it to sit into, and I've got my screw hole over here. So what I'll do first of all is just get this screw in, because what it will do is it'll put it all in place, and it'll mean I don't have to worry about it moving around whilst I've got it in the chassis. So we'll get him in place first. Easier said than done when you're trying to reach over. So, okay. So that's that one in place. Now this transistor over here, if you remember, this one doesn't require any isolation, and it goes straight onto the aluminium. And it then has this little metal bracket that just pushes it against the chassis. So I simply on this one need to pop him where I want him to be, begin to tighten him up, get it adjusted so I'm happy. So you don't want it right down, you want it sitting so the bar is level against the transistor, or triac, depending on which one it is. I haven't actually looked on this. So you can see that one is now biting, and that is holding that one nicely against the chassis. Now again, on these back ones, we need to make sure that the isolation is in place correctly. So what we're going to do is just make sure that the screw hole shows. There's a little bit of space to move him over. Make sure that the transistor is in place. Now you can see on these, the way they've installed these originally is quite poor, if I'm honest. Looking at it, the way the soldering actually is it's actually pushing the transistor off to one side. It's nothing to do with anything I've done. That's just the way. Now, I'd be inclined usually to try and do something about that, but I'm not going to do it today on this one. But what I am going to do is just a bit of that thermal compound I've put on is run a little bit lower than I would have liked. Okay, so that's now done. I'm happy with that. So what we just need to do now is line up the thermal pad, because it is only in a certain position that it fits. So we're just going to get that in the right place. And then get the bracket installed back on top of this. And again, the way it works, it's just a metal bracket that goes on the front of the two ICs as we begin to tighten down. So we're just going to pop the screw on and get it started. And then when we're happy, we're just going to put him in place, make sure it looks correct, and then tighten him down, gentle pressure, just to then make sure that they are clamped against the chassis, that they do have the thermal compound behind them, and that they are held in place nice and tightly. Now, as I said, the soldering on these is pretty shocking when you look at it. If I'd have spotted that when I actually took it apart, I'd have probably leveled that up a little bit just to give it a bit of better thermal hit on the back of the chassis, but no. So the next thing we're going to do is button it up, power it up, and check it's working. Okay, so the PSU is back together. Time to put it back in the chassis, wire up the mains connections, and then get the multimeter on it and see how it looks. Okay, so the first job is to get the PSU back in place. I've just placed it in, and then I've got some screws that I need to pop down. It's not actually the easiest of jobs, this. And they were positioned just so they screw in next to each other. And the reason I actually did that is the PSUs actually touch. And the reason for that is so they can actually share a bit of the thermal on the heat sinks between each one as well. There's a screw there, and then there is one down in that gap down there, which is a little bit challenging to get to. And again, what I actually did when I built this, as you can see, is I actually put a plywood base in. Not ideal from a fire point of view, let's just say. However, from a keeping everything in place point of view, it actually worked out very nicely. And one of the other mods I did later on was actually adding this regulator for the chassis fan, just to keep it all cool, because when I moved it from the TB47s to the TB50s, she started to get quite a bit warmer in use compared to what it used to be. So I decided to upgrade it. So the next thing we're going to need to do is do the wiring. I've just come over to get myself a proper screwdriver for doing this bit. I'm going to want some of my slightly larger ones for doing the connection wiring. And again, we want to make sure I actually get this right, because if this goes wrong, it will end very, very badly indeed. So what we're going to do is get you out of the way. And interestingly, on this power supply, I actually had the feed for the regulator on this one as well, interestingly. So what we're going to do is get all the wiring out of the way first, and then it's time for me to then figure out what went where. Now, the very simplest is the live and neutral on these, which is the mains, and they are all looped actually, these, and this is actually the one where I had the mains input looped through as well. So again, it's going to be one to make sure I do get right. So we're going to want the neutrals and the lives done first of all. Next is the lives. And the problem is, the way I did this was I didn't actually leave any space in this thing at all for making life any easier when building. It was very much done with little future thought, unfortunately. So when it comes to getting a lot of the wiring in, let's just say it is a little bit challenging. Okay, so we've got the live and neutral, so they're looped through. Then we've got the earth to do, which again is very important, because if we are linking supplies, there are 4 supplies in this, all linked together. You want to make sure that you do have a good earth between them all should something go wrong. And whilst this case is mostly made of wood and plastic, it is not officially double isolated, so there is no official protection in there for actually things like full-on earth shut faults. So you do need to make sure that you do have your wiring correct. So again, if we compare it to the one above, we've got our live, neutral, earth, and this is where it gets a bit more difficult because the PSUs are actually linked, and I need to make sure now that I get all the wiring correct for the DC side, because I actually ended up using all black cable because I didn't have anything of the right colors at the time. So I do need to make sure I get this bit right. Okay, so everything's back in the chassis. I've got my multimeter here to do some tests. So what we're going to do now is fire it back up. Check it's working, but check what voltage we've got, because I can't quite remember what I need to change it to. I probably are going to have to tweak it again because I've had it apart. I'll check the voltage on the power supplies. I thought off the top of my head it was 26.4, but I could be totally wrong. We'll have a look now. So what we're going to do is fire it up. We've got no smoke, which is good, and we've got a green light now. You probably can't see it on camera, but we do have a green light on this PSU, which tells me it's up and running. Now, I have to be very careful in here because there is live 240 mains voltage just there on that connector, which would do me a lot of damage. Also, down here as well, as you can see, one of the relays is kicked in over there as well. So what we're going to do now is take a quick look at what kind of voltage we're actually getting out on the DC side on this new supply, or this repaired supply I should say. So we're going to go on to the DC, onto the voltage out, and we're getting 26.29. Actually, thinking about it, I'm sure it's 26.3 I want. So that's 26.29, which is fantastic. We weren't getting that before. Let's check it on one of the other ones, see what we're getting on them, because these are all configured correctly. 26.37 on that one. What's probably just as easy is to measure up here at the output points. This one is giving us, that one's off, 26.33. I think this is the new one. And what I might actually do is 26.29. I might take this as an opportunity to retune a couple of these as well, actually. 26.36, because I haven't done it since I built the original charger. So he is a little touch down. So what I'll probably do is take this as an opportunity to adjust it. I'll do a voltage check on the original Inspire 2 one, which I've got over there on the bench, and we'll come back and actually tune all of these individually again, because that isn't something I actually did on this one. Okay, yeah, so we're slightly over voltaging, which I think I was doing on the Inspire 1 actually, and the reason for that was that the packs actually preferred 26.3 volts rather than 26.1. But what we will end up doing is now just doing some adjustments on these to get these supplies down to 26.1 to align them with what we were doing before on the other charger. And it is, when you do this, it is quite an awkward task, if I'm honest. 26.11 on that one. I will take that all day long. We'll then move over to this one. And whilst these front two are the easiest ones to do, it's the back ones that are going to be slightly more challenging. 26.3. And it is a tad of an adjustment on these, it really is. It's literally a hair of an adjustment. Oh, 26.11, we'll take that one for that one. Okay, so that's all of the voltages done, and just to show you guys where we're at, if I go on to the prongs at the top here, you can see that we are getting 26.13 on that one there, just over the 26.1. I'm more than happy with that. 26.12, happy with that one. Try and get this one across without getting my arm in the way. 26.12, and then over to the last one, and then 26.12 on that one. So all outputs are looking good, and she's ready to go back together. Okay, and that's pretty much it. So it's all done and dusted, ready to go back together, and we'll just test it now to make sure it's all up and working as we expected. So whilst it does look an absolute horrendous mess, it does actually work, and it does an actually good job. And as I've said, relay board, Arduino controlling the voltages to get the batteries in. So what we're going to do now is pop him back together, get my cable tucked in the back corner there, screw the top back down. Okay, and then fire him back up just to see if it's working okay. When you turn it on, I get my display come up, and I actually programmed it to put a little bit of a message, and I actually did program it when I built it for the Inspire 2 and changed the name. Wait for it to kick in, and then we'll have a look at all the voltages. What it's doing is it has a boot sequence for the Arduinos, and boom, 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 26.0, 26.0, 26.1, 26.1, which is bang on. There's a slight, variance, 0.1 on the displays. Really, it is pretty much it. So, all good. And as I said, the way it goes, we simply take a TB50, which I've got over here. We take the TB50s. You simply take the battery, drop him in to the housing, and then it will actually start to charge, and this is in number 4, so it's jumped into that one there. And if I want to, then I can simply flick it into that mode there, drop the switch down, and then it'll actually cut the charging off just like it's actually done. But yeah, straightforward as that. So she's all done and up and running, and hopefully it'll give me another few months of use until the next one of those capacitors go. Now really what I could have done is taken all the power supplies out and replaced all of them, but I wasn't really up for doing that today. That is it for this video. I hope it's been helpful. It's a bit of a scrappy one just to give you guys an overview of this. Again, if you've not seen this in use, please do check out my other videos on the channel about it. It's a good little project, one of the best ones I think I've done for a long time, and yeah, this thing has been absolutely invaluable. It really has. That's it. Please do subs, and I will do another video again soon.